So just to note, most of the things we've multiplied so far have had the numbers in front of the x's, the coefficients of the x's, be 1. When we factored every single time, that number in front of the x has been 1. Well, we're going to step it up now, and we're going to change so that coefficient in front of the x squared term is not going to be 1. And I'm going to show you a quick shortcut method to try to factor these. These can get tricky, but we have a nice little shortcut that I think will work well for us. Just a reminder, we're foiling these out. We cannot predict the final middle term here by looking at our outside and inside because of that too. Everything kind of changes now. So I'm going to multiply 2x times x would be 2x squared. 2x times minus 3 would be minus 6x. And then I'll go back and pick up that 1. 1 times x would be plus 1x. And 1 times minus 3 would be minus 3. And again, combining those like terms, I get 2x squared minus 5x minus 3. And what I notice here is this is different from the ones we've done up to this point. There are not factors of negative 3 that add to negative 5. And the reason for that is because of that 2 in front of the x squared term. I can't factor as easily as I did the other ones. But fortunately for you, we have a senior in school now who developed a method when he was a freshman. I'm going to show you right now. One of the ways we can try to factor these is through the old guess and check method. So if I'm trying to factor 3x squared minus 7x minus 6, again, it's going to be difficult because of that 3 that's in front of the x squared term. I know if I tried to factor these, I would have 2 parentheses. And those 2 parentheses, I know when I FOIL this out, my first times my first would have to multiply to be 3x squared. So I'm guessing I'd have 3x and x. But that's really all I know. I can't find numbers necessarily that multiply to 6 and add to 7 because of that 3. Things are going to get messed up. I could do a lot of different choices here. These last 2 numbers have to multiply to 6. Well, they could be 6 and 1. Or because of that 3 would get multiplied by the 1 and not by the 6. Maybe it's 3x and 1 and x and 6. I don't know yet. Or maybe it's 3x and 1 and, 3x and 2 and x and 3. I still need those last 2 numbers to multiply to be 6. Maybe it's 3x and 3 and x and 2. I don't know yet until I dive into the problem. So guess and check would tell me, let's try all of those until we hit the right answer. This guess and check method is not too bad if you make the right guess the first time, but sometimes there's a lot of combinations that we have to try until we get to the right answer. So if I tried all of these, what I'd have to do is figure out through my pluses and minuses and foiling them all out if I end up with that 7 in the middle. So let's see, if I multiply here, I know when I multiply the first 2 numbers, I'm going to get 3x squared. And I know when I multiply the last 2, I'll get 6. So what I really want to check is the outside and the inside. That would give me 3x and 6x. There's no way I'm going to get 7x through those 2 numbers, so it's not this option. This would give me, checking the outside, 18x, and the inside, 1x. Again, I'm not going to get to that 7, right? This one would give me 9x and 2x, and that's where I'm going to get my 7 from. I need to get my signs right. I should have a negative 9x and a positive 2x to get to minus 7x. So I'm going to put a minus there and a plus there, and there is my answer. So through some guess and check work, we can get there. But I'm going to show you a shortcut method that, again, one of our seniors, Cole Fitzgibbons, created this when he was a freshman. When Cole was a freshman, we called this, his last name again is Fitzgibbons, we called this Fitzy's method. So Cole noticed something interesting. He said, I'm going to take these 2 numbers and multiply them together, and I'm going to play that x game that we did before. I want 2 numbers that multiply not to negative 6, but to the product of the first and the third number, so to negative 18, that add to negative 7. And those numbers through some trial and error would be minus 9 and plus 2. We see where those come from. Again, 2 numbers that multiply to negative 18 and add to negative 7. So Cole noticed, let's do this. Let's use this number, that 3, 3x and 3x, and I'm going to write that 3x twice. Whatever that number is, I'm going to write it twice. And then I'm going to do minus 9 and plus 2. But then Cole said, wait a minute. And again, the minus 9 and the plus 2 came from those two numbers. Cole said, wait a minute. This factor has a common factor. 3 and 9 share a common factor that I don't need. I'm going to toss out that common factor. I'm going to divide by that common factor. That common factor would be 3. And if I divide by that 3, I'm going to get x minus 3. The 3x and the 2 don't have a common factor, so I don't need to throw anything out. I get x plus 2, and there is my answer, which is the same answer we got in the last slide, because it was the same problem. So Fitzy's method, kind of a nice, easy one. Let's look at a couple more examples. I'm going to walk you through this one with the directions written over on the right. Now we call these kind of trinomials, we write them as ax squared plus bx plus c. So if I'm referring to an a or a c, I'm talking about those numbers on the outside. The b is the coefficient of that middle term. So Fitzy's method says to multiply a times c. So in this case, 6 times 4 is 24, and that number's going on the top of my x. The middle number, that b, goes down here. And what I'm looking for is two numbers that multiply to a times c, multiply to 24, and add to 11. In this case, 8 and 3 will work. And then Fitzy said, we're going to write these parentheses as ax, a in this case is 6, 6x, plus, I called it factor 1, so plus 8. And then that same number, 6x, plus 3. It's not 6x and 6x, because that would give me 36x squared, which is not what I want. But this last step of throwing away any common factors for either parentheses is going to take care of that for me. It's going to get rid of the extra numbers I don't need. So I'm going to look at these individually, looking at these parentheses. Is there a common factor between 6 and 8? Yeah, there's a 2, so I'm going to throw it away. I'll divide each of those numbers by 2. I get 3x plus 4. For that second set of parentheses, any common factor between 6 and 3? Yeah, there's a 3 in both of those. I'm going to throw the 3 away. Divide by 3 gives me 2x plus 1. And if I FOIL that out, I get 6x squared plus 3x plus 8x plus 4, which gives me that 6x squared plus 11x plus 4, and I have the right answer. Okay, so those 4 steps, if we can memorize them, they're pretty quick and easy. Let's do one more. So same idea here. I'm going to multiply the a times the c. So multiply the first number times the last number. Paying attention to signs, I get negative 6. At the bottom, I'm going to put 1. That's my coefficient of the middle term, or my b. All right, factors of negative 6 that add to 1 would be 3 and negative 2. And I'm going to write out my parentheses, 3x and 3x. And again, I'm using that 3x too many times, but it's all going to work out for me when I throw away the common factor. 3x plus 3, 3x minus 2. And again, I'm not quite there because I want to throw away any common factors that I have. These two numbers have a common factor of 3. If I divide by 3, I just get left with 1x plus 1. No common factors over here, so 3x minus 2, and there's my answer. So our goal today is just practice these, practice. We want to get relatively good at them because they're going to keep coming up for the rest of your math career. All right, so we're going to practice those today. Thanks, guys. Have a good day. Hope to see you soon.